In this video, we are going to discuss about object detection. So this is very important in the concept of deep learning because we give more focus and importance on object detection right now. So we are just going to understand what is object detection and how does it work. Okay, so just look at this picture. I'll give you 1 minute of time. Just quickly go through this picture and just try to understand what is. Just share your understanding about it. Just you have a quick go through about the understanding about the picture. Yes, right. So just let us deep dive about this picture first of all. You could see some cars, trucks, and some persons. She has a bag also. So here also you can see some bags, and then here we could see some objects, right? So this is what we observe. Say we are human beings. When we look at an image or when we look at the world, we can identify what is what. Say if you look at the car, immediately your brain recognizes that it is a car because already we are trained into that. But just imagine how the computer will identify a car, how the computer will identify a person or a handbag or a truck or eyes or whatever it is. Like when you show an image, how does a computer recognize the objects in the image? This is really challenging, right? So this is what being done by the computer vision. So let us try to understand what has happened and how the object detection is being done. Now look at this picture. Just imagine how the computer is identifying, how the machine is identifying a dog and a cat. So you can see a box over here for a dog and another box over here for a cat, right? It is labeled as dog and cat. So you could see a box also over here, right? So what is object detection? So it is easy for humans to detect and identify the objects present in an image. Now we have large amount of data and we have computing resources, and using that we are training the computers to detect and classify the objects in an image with high accuracy. So the problem of identifying the localization of an object in an image is called as localization. So this is possible with the help of deep learning only. So nowadays, deep learning networks are very good at image classification than humans, which shows how powerful the technique is. We as humans do far more than just classify images when we observe and interact with the world. We also localize and classify each element within our field of view. So these are much more complex tasks which machines are still struggling to perform as well as humans. But in fact, I would argue that object detection, when performed well, brings machines closer to real scene understanding. Right? So now there are convolution neural networks which does this kind of task. Now there are another techniques also like RCNN, and there are some more variants of RCNN like fast RCNN, faster RCNN, mask RCNN, SSD, and YOLO, right? So let us try to have a little more understanding about it. Like what is RCNN? So by a few years ago, what happened? The computer vision made everything possible with the help of convolution neural networks. Then the researchers developed RCNNs to deal the tasks like object detection, localization, and classification. So broadly speaking, RCNN is a special type of convolution neural network that's able to locate and detect objects in the images. So how do we get the output in this? So the output is generally a set of bounding boxes that closely match each of the detected objects as well as the class output for each detected object. Do you get my point? So, we all know that how the convolution neural networks work, right? So RCNN is also doing the same kind of task, right? So nowadays the achievements what we got is truly amazing, and yet none of the architectures managed to create a real-time object detector. So let us try to understand this. What are the problems with some kind of convolution neural networks? What we have identified is training the data is unwide and it is too long. And also the training happens in multiple phrases. Say there will be a training region proposal and also the classifier. The network is too slow at inference time. What does that mean when it deals with the non-training data? So fortunately, in the last few years, new architectures were created to address the bottlenecks of RCNN and its successors that enabled real-time object detection. So the most famous ones are SSD, which is nothing but single shot detector, and YOLO, you only look once. So SSD, single shot detector, takes only one single shot to detect multiple objects within the image. So RPN means regional proposal network based approaches like RCNN series requires two shots. One is to generate region proposal and the other one is to detect the object for each proposal. So SSD is much faster when we compare it to two-shot RPN-based approaches. RCNN tends to very inaccurate. The biggest problem with RCNN family of networks is their speed. They were incredibly slow. So to help increase the speed of deep learning based detectors, both the single shot detectors and YOLO use one stage detector strategy. So these algorithms treat object detection as a regression problem, taking a given input image and simultaneously learning bounding box coordinates and the corresponding class label probabilities. So generally, single-stage detectors tend to be less accurate than two-stage detectors, but are significantly faster. We will study everything in detail, right? Have we seen this before? So we all know how CNNs work. CNNs can be used to detect and classify objects in an image. CNNs are feed-forward artificial neural networks where connections between the nodes do not form a cycle. So the basic architecture of CNN contains different layers like convolution layer, pooling layer, and again convolution. So basically convolution layers, pooling layers, fully connected layer, that is basically the output. So the convolution layer and the pooling layers act as a feature extractor, and so these convolution layers and these layers, right? So in the convolution layer and the pooling layers act as a feature extractor. That's what I said, right? And the non-linear transformations of the extracted features, and it acts as the classifier. So let me repeat it. The convolution layer and the pooling layer, it acts as a feature extractor, right? So these acts as the feature extractor, right? And the fully connected layer, what does this do? This performs the non-linear transformations. Non-linear transformations of these extracted features, and it acts as a classifier, right? So in the convolution layer, the convolution operation takes place, which is nothing but a weighted sum of the two functions, right? So once after the convolution layer, the pooling layer is used, right? So what is the purpose of this? It is used to reduce the number of trainable parameters. So there are like maximum pooling and average pooling. Mostly we use maximum pooling. So after using convolution layer and pooling layers, the output is required in the form of a class. So the convolution and pooling layers are used only to extract the features and reduce the number of parameters from the original image. So, but in order to obtain the final output, the fully connected layer is applied to generate an output equal to the number of classes we need. So what are the steps involved over here? We input an image, right? We input an image, and then what will happen? So let me write the steps, no? So that would be better. So we input an image. So that is the step number 1. So in the second step, it divides the image into different regions. So it divides the image into different regions, right? Then the third step is that consider, now here there are different regions, right? So each region will be considered as a separate image, and these regions will be passed to CNN, which will classify them into different classes, right? And then again, all the regions will be combined to obtain the original image, with the objects detected in it. So what are these steps that are involved in detecting and classifying objects in an image? So there is an input. So we will input an image. Now the image will be divided into different regions. Now each region will be passed to CNN, which will classify them into different classes. Now all the regions will be combined to obtain the original image, which detects objects in it, right? So hope this is clear, right? So now let us go back to the previous image, and we will try to understand that, okay? So that is what happened here. So we have given this as the input. Then what is it doing? It is making different regions, okay? So here a person, the other person, car, everything is made into different regions. Then each region is fed into the convolution neural network, and it will predict that. See, actually the first step, it is not identifying what it is. So it is passed to the convolution neural network, and the convolution neural network is classifying that this is a person, this is a car, this is a bag, right? So this is what being done by CNN. Now all the regions will be combined to get the original image with the objects detected in it, right? So what is the problem in using CNN for this object detection? The objects present in an image may have different aspect ratio, and the spatial locations also, in some cases, in some object would be very big, and it may occupy the whole, or in some case it might be very small and it occupies a very small region of the image. So the shape of the objects are also different, right? You can see here the shape of the objects are also very different. So a large number of regions are required to detect and classify the objects accurately, which will result in massive computation time, right? So thus, to reduce the number of regions, RCNN is used so that it selects the regions using a proposal method. So the object detection can be done with the help of RCNN. We have discussed what are the problems we faced with the CNN, right? So that RCNN is adopted. And here actually selective search is used to extract just 2000 regions from the image, which are known as region proposals, which was proposed by Girshik et al. And he proposed this selective search method, right? So in CNN, we have to deal with the classification of large number of regions. But in RCNN, we need only to work with the 2000 regions. So these 2000 region proposals are generated using the selective search algorithm. So the 4 regions which form an object can be regarded as according to the varying scales or the colors or the textures and the enclosure. So what the selective search does, the selective search tries to identify the patterns in the image, and using this it proposes different regions. So what are the steps in the selective search, right? So step 1, we input an image and generate initial sub-segmentations, right? So we input an image and generate initial sub-segmentations to obtain multiple regions from the image. Then these regions will be combined to form a larger region that is based upon the color similarities, texture similarity, size similarity, and shape compatibility, right? And shape compatibility, right? Hope this is clear, right? So we are combining several regions. So first, what are we doing? We are inputting an image and we are generating initial sub-segmentations. We are, in the sense, RCNN is generating sub-segmentations to obtain multiple regions. So now you can see that there are greens, right? So that will be combined to, those regions will be combined to form a large region based upon the color similarity, texture similarity, size similarity, and shape similarity. Now the regions will produce the final object detections, right? So what is the selective search? Selective search is basically a region proposal algorithm which has high recall, and that is used in object detection. So the algorithm inspires from the hierarchical computing and grouping of similar regions based on the color, texture, size, and shape compatibility. So that is what I told, right? So what it will do, it begins by over segmenting the image based upon the intensity of the pixels, and uses a graph based segmentation method, and it over segments it does the over segmentation. So when you pass an image, it does the over segmentation. So the selective search algorithm takes the over segments as initial inputs, and then it performs the procedure. So the step 1, it will add all the bounding boxes. Say there is a cup, coffee, glass, right? So it first it adds up all the bounding boxes, and then corresponding to the segmented parts of the list of region proposals, and then it groups the adjacent segments based upon the similarity. Then again it go back to adding all the bounding boxes corresponding to the segmented parts of the list of region proposals. So the selective search uses 4 similarity measures like color, texture, size, and shape compatibility, right? So during each iteration, larger segments are formed and it is added to the list of the region proposals. So a bottom-up approach will be incorporated to create a region proposals from smaller segments to larger segments, and this is referred to as computing hierarchical segmentations, right? So now how we can detect RCNN, right? So now to detect objects using RCNN, there will be a series of steps that will take place. So we need a pre-trained CNN is taken, which is then retrained on the last layer of the network based upon the number of classes which are needed to record. Then we need ROI, that is region of interest for every image is taken, and then these regions will be reshaped to match as per the size of the CNN. Then the regions are obtained. So a linear support vector machine, SVM is used over here to train. It is trained to classify the objects as well as the background. For each class, one binary SVM is trained. And in the last step, what we have is a linear regression model that is trained to output tighter coordinates for the box once the object has been classified in the image, right? So what we can see here, one convolution neural network. So you can see that B-box reg SVMs. and then again the B-box regression and DSVMs, and then B-box regression and DSVMs. So it apply bounding box regressors, and then it classify the regions with SVMs. Here it forwards each region through convolution network, right? So basically this is what happening, right? So this is the region of interest basically. So let us try to understand this. A pre-trained CNN is taken, which is retrained on the last year of the network based upon the number of classes. That is what we saw already, right? So now the region of interest from the proposal method is taken, and then these regions are reshaped to match as per the size of the CNN. And now the whatever is being done, that is forwarded through SVM classifier to classify the objects and the background. Last step, we apply the linear regression, right? So what are the limitations of RCNN for object detection? So here, as I told you, like the number of regions is chosen as 2000 per image, but still it takes an enormous amount to classify the regions. So it is not possible to implement for real-time applications because it takes 47 seconds to predict for a new test image. So the selective search algorithm is a fixed algorithm. So no learning takes place in that stage, which in turn leads to generating bad candidate region proposals, right? So that is what. So hope if you look into this, it will give you a clear idea about this object detection, right? So hope you understood the concept of what is object detection and how it is being done with the help of it. So the RCNN was adopted for object detection due to a large number of regions in CNN.